Everyone today is used to playing online games. You press a button and your character moves or attacks. It feels instant. But in reality, there is a lot of complex technology working in the background to make all of this possible. In this video, I'll explain how game networking works, why you face latency issues and packet loss, why matchmaking is so hard to get right, and what clever tricks developers use to make online games smooth and fair. As always, let's start with the basics, how games use the internet. When you play online, your game doesn't magically know what other players are doing. Your game client, I mean the game running on your PC, mobile or console, talks to a game server. And this server keeps track of everything: player positions, health, ammo, scores, and who shot who. Your client collects your actions, like moving, jumping, firing, and sends them as small packets of data to the server. The server processes them and then sends updated information back to all players. It looks somewhere like this. Your game sends a message, I spawned on base, and the server sends messages to everyone in the lobby saying, player X spawned on base, so everyone clients can adjust and spawn you right there. Where the server is matters a lot. If it's in another country, your data has to travel thousands of kilometers, jumping between internet providers, and that takes extra time. That's why most big games have servers in different regions. North America, Europe, Asia, so players can connect to the closest one. But servers don't just handle your actions in the match. All the global data about your account, things like your name, level, unlocked skins and in-game currency, is stored in databases. A database is basically a big organized storage system, where information can be saved and updated very fast. Every time you get coins, finish a quest or level up, the game server updates that database, so your progress is saved for the next time you log in. Without these databases, you would lose all your progress as soon as the server restarts. Now, what about Voicechat? It works almost the same way. Your microphone records your voice, compresses it, cuts it into packets, and sends them to the server, or sometimes even directly to your teammates. Their games reassemble the packets and play your voice almost instantly. If some packets arrive late or get lost, your voice will lag or sound robotic. Of course, these systems aren't perfect. That's why we run into latency issues and packet loss. Latency, usually called ping, is the time it takes for your action to reach the server and come back. If you have a 20 milliseconds ping, the server reacts almost instantly. But if your ping is 200 or even more, you start to notice delays. Depending on the game, pressing shot might take half a second before the gun actually fires. High ping can happen if the server is far away, your Wi-Fi signal is weak, or your internet connection is overloaded. Packet loss is different. It's when some of the packets simply never arrive. Imagine sending 5 messages, but 2 disappear on the way. The game then has missing information. That's when you see players teleport around, or freeze for a moment, and then suddenly appear somewhere else. The game is trying to guess what happened while waiting for new data. So how do developers fight these problems? They use clever tricks to make the game feel smooth even when the internet isn't perfect. The first important trick is prediction. If you press W, your game moves your character forward immediately, predicting what the server will send later. Most of the time, this works perfectly. But if the prediction was wrong, for example, if you hit someone on your screen but the server disagrees, you will see the correction after. That's why sometimes you see blood effects from an enemy head, but the game says you missed and the enemy still has full HP. Another trick is interpolation. Instead of showing other players' positions only when packets arrive, the game smoothes the movement by filling in the gaps. That way, even if data comes in slightly late, characters move smoothly instead of jittering around. Then there is lag compensation. This one is very clever. The server knows players have different ping, so when a high ping player shoots at you, the server might rewind time to the place you were on their screen when they fired, and then check if the shot hits. Without this, high ping players could never hit anything. With it, they can still compete, though sometimes it feels unfair for low ping players, like you getting killed while already being behind the wall. Developers also use packet prioritization. As you know, not all data is equally important. The game always makes sure that movement and shooting packets are delivered, while less critical things like animations can be delayed or even dropped if the connection is bad. Finally, there is compression. To save bandwidth, all data like movement, actions, voice chat is compressed into very small packets before being sent. The smaller the packets, the faster and more reliably they move through the network. If you find game dev overall interesting, don't forget to check my gamedev Patreon linked in the description, with a lot of beginner-friendly articles and guides. You know, online gaming is not only about smooth movement, another huge part is matchmaking. When you press find match, the system has to choose teammates and opponents for you. Sounds simple, but it's actually a pretty hard part of online gaming. Most matchmaking systems use skill ratings like MMR or ELO. Every time you win or lose, your rating changes. The system then tries to match you with the players with similar ratings, so games are fair. But skill is not the only thing that matters. The good system also looks at ping, trying to balance connection quality. There is also queue time. Most people don't want to wait 20 minutes for the perfect match, so the system slowly widens the search the longer you wait, allowing a bigger range of skill or slightly higher ping players. I think you got those lobbies a few times with really big skill spread. So it is a trade-off, speed versus fairness. Some games even consider behavior. If a player leaves matches often, is reported for toxic behavior or cheats, they may get placed in separate pools with other problematic players. Meanwhile, well-behaved players might get slightly better teammates. By the way, to increase your behavior score and greatly help with the channel, please like, sub and comment. And don't ever do the next thing – cheating. Cheaters ruin games with aimbots, wall hacks or different exploits. Developers are always fighting them, and it is an endless battle. The first line of defense is server authority. The server is the final judge of everything. The client can just say, I killed the boss in one shot. A properly made server checks if that's possible based on your stats, weapons and positions. And if not, it simply ignores the request. This prevents many simple cheats. Then there is anti-cheat software. Programs like Easy Anti-Cheat or VAC run in the background, scanning for known cheat tools. If they find something suspicious, they ban the player. Of course, cheat developers constantly update their hacks, so it is a cat-and-mouse game. And finally, there is data analysis. If player has 98% headshots or reacts faster than humanly possible, the system can flag them. Some games even record these suspicious matches for review by AI or human moderators. As you see, online games only look simple, but under the hood they are full of tricks, fixes and hidden systems, just to keep things playable. And when something breaks, you really notice. Don't lose the momentum, go on and watch this next cool video about the different ways how games simulate destruction. Good luck, make 10 squads, I will see you very soon, we are still on the internet.